So good day guys, here we are again at Sir Mike's virtual class and we are again going to discuss another lesson. So without further ado, let me introduce our lesson for today. Our topic is about bivariate data. And again, I am your teacher for statistics and probability, Sir Michael Gallardo, teacher 2 from Orani National High School, Maine. Let us begin our lesson. So at this point, we are going to measure how much do you know in terms of our topic today. So here are some questions. Don't worry, this will be recorded but not graded. Let's begin with the questions. Read and analyze the questions below. Write the letter of the correct answer on your answer sheet. First question. What type of data or data uses two sets of variables that can change and are compared to find relationships? A. Bivariate, B. Univariate, C. Qualitative, and D. Quantitative. Write your answer on any piece of paper. Number 2. What type of variable is controlled or influenced by an outside factor in an experiment? A. Random, B. Discrete, C. Dependent, or D. Independent. Next question. Which term means a graph with points plotted to show a possible relationship between sets of data? A. Line of best fit, B. Scatterplot, C. Correlation coefficient, and D. Two-way table. Write your answer. Number 4. What is an outlier? A. A type of variable that cannot be quantified. B. An extreme value at either end of the distribution. C. A score that is left out of the analysis because of a missing data. Or D. None of this. And for the last question, for the first part. What kind of a relationship could be concluded between the x and y variables from the scatter plot on the right? So you have there our scatter plot on the right. A. Strong positive correlation. B. Strong negative correlation. C. Moderate positive correlation. And D. Moderate negative correlation. So for the part 2 of our pretest, so what do you think? For each of the following pairs of variables, identify the independent variable and dependent variable. If it is not possible to identify these, then write not appropriate. So what type of data or data uses two sets of variables that can change and are compared to find relationships? So I will give you 30 seconds to answer this question. Okay, let's you may check your own answer. Check it with honesty. As I have said before, this will be recorded but not graded. So there's no need for you to cheat, and you should not cheat because this is just a measure of how much you know about our lesson for today. But hopefully, if you get a low score, um, there should be an improvement at the end of the lesson. So for the answers in how much do you know? For number 1, the answer, what type of data or data uses two sets of variables that can change and are compared to find relationships? The correct answer is A. Bivariate. Number 2, What type of variable is controlled or influenced by an outside factor in an experiment? A. Random, B. Discrete, C. Dependent, D. Independent. The correct answer is C. Dependent. Number 3. Which term means a graph with points plotted to show a possible relationship between set of data or data? So the correct answer is B. Scatterplot. Number 4. What is an outlier? A type of variable that cannot be quantified. B. An extreme value at either end of the distribution. C. A score that is left out of the analysis. Or D. None of these. The correct answer is an extreme value at either end of the distribution. And for the number 5, what kind of a relationship could be concluded between the x and y variables from the scatter plot on the right? A. Strong positive correlation. B. Strong negative correlation. C. Moderate positive correlation. Or D. Moderate negative correlation. So the correct answer is a moderate negative correlation. So the answer for number 5 is letter D. So for the second activity, or the second part of our pretest, for each of the following pairs of variable, identify the independent and dependent variable. For number 6, the answer is for the dependent variable, it is the salary. And for the independent variable, that is the age of a basketball player. Sorry for uh, um, the word age was not included in the answer key, but it should be the age of a basketball player. So that is our independent variable. Now, for number 7, our dependent variable is... Okay, the answer is not appropriate because we cannot determine whether which of the two variables is related or dependent upon the other. So this the answer for number 7 is not appropriate. The answer for number 8 is for the dependent variable, we have the cost of grapes, and for the independent variable, the season of the year is the answer. Number 9, the answer is not appropriate. The mark obtained in a math test and the mark obtained in an English test, we cannot determine which is the dependent or independent variable. And for number 10, the mark obtained for a math test and the number of hours spent preparing for the test, so our dependent variable is the mark obtained, and the number of hours studying is our independent variable, or the number of hours spent preparing for the test. So there you have it. So today we have encountered these words: independent variable, dependent variable, bivariate. What do these words mean? I know they some terms are familiar. We just have to contextualize it based on how it is used in um, statistics, because I already know, or you already know, what a dependent variable is and an independent variable is in terms of mathematics, specifically with the previous subject that we had. Okay, so now how are these two words um, used in context with statistics? So let us now unlock these terms. So before we begin with our lesson, or before we go on with our lesson, our objectives are, so after going through this module, you are expected to illustrate the nature of bivariate data or data. Number 2, construct a scatter plot. And number 3, describe the shape or form, trend or direction, and variation or strength based on a scatter plot. So let us now proceed with our actual lesson. So we have to be familiar with these words so that we can use this and understand this understand our lesson better. So univariate and bivariate. Our lesson is about bivariate data. So if there are bivariate data, there's also what we call a univariate data. So what is the meaning of these two? From the word uni and bi, what do you think is the meaning of uni and what do you think is the meaning of bi? So when we say bicycle, how many wheels does it have? So it has two wheels. Okay? But when you say unicycle, how many wheels does it have? It only has one. So when we talk about univariate, it means the data involves only one variable. So let's say um, um, in an if you have your IDs with you, an example of a univariate variable is your LRN or your learner's reference number or even your gender or your sex. It can also be your section. So those are univariate data because they are only one variable. But today, our lesson is about bivariate data or data that involves, data that involves two variables. It should be two variables. I'm sorry for the typographical error. So when you say two, the data involves two kinds of variable. For example, what we had earlier um, in the exercise, the age of basketball players and their salary. So those are two variables. Another one is the season of the year and the cost of grapes. So we can see that we have two, or we are talking about two variables. And we have this two kinds of variable. Independent variable. Independent variable is a standalone variable. Its value can change, be controlled and manipulated without reference to another variable. It means it is a standalone. It is not dependent upon other variable or it is not affected by other variable. Unlike the dependent variable, it is a variable that is influenced or affected by the independent variable. You may remember this in general mathematics that when you change the value of x, y also changes. Okay? So x is an independent variable and y is a dependent variable because its value depends on variable x. So let's go back to our example a while ago. So we have here two um, two variables. Number 6, the dependent variable is our salary and the independent variable is the age of the basketball player. So we notice that what do you think happens when a basketball player is young, and do you think there is a relationship between the age of a basketball player and his salary? There might be a relationship. Okay, so how about is the salary or is the age of the basketball player dependent upon his or her salary? Of course not. Okay, so maybe the salary is dependent to the age of a basketball player, but not the other way around. Another example, number 8. The cost of grapes, that is our dependent variable. It is dependent because it is dependent on the season of the year. If it is the season for harvesting grapes, so definitely the cost would be lower than in the season of the year when it is not the harvest time for grapes. So we can say that the cost of grapes is our dependent variable. And the number 10, of course, our independent variable is the number of hours studying. And depending upon the number of hours studying is the mark obtained for the math test that the student is going to have. So there you have it, our independent and dependent variables. So when we talk about bivariate data, we are looking for the data or data from two variables. So activity 2, construct a graph for the given data. Draw and label the coordinate axis and then plot each point using a graphing paper. I know you are familiar with graphing in the x and y coordinate, but this time instead of having 4 quadrants, let us take only the first quadrant, the positive values for x and positive values for y. I know you're familiar with this, that's why I'm not going to give another example. You may use a graphing paper, or if you do not have a graphing paper, you may use your notebooks. Okay, for the first graph that I want you to construct, we have the age of a person in years, that will be your x variable, and his weight in kilograms, that will be your y variable. For the second graph that you are going to make, we're going to for our x axis, we're going to have the number of hours spent in safety training, and of course for the y value, we have the number of hours lost due to accident. So I'm giving you 5 minutes to do or construct a graph using these uh, two variables that we have, x and y. So you're going to construct 2 graphs. Your timer starts now. So right now, okay, after the 5 minutes has elapsed, let us now proceed with, let us see if your answers are correct. Now, for the graph of the first bivariate data that we have, for the x value, we have the number of hours, that is the age of a person in years. So that is what it should look like. Okay? Later on, I will explain the meaning of weak positive linear relationship. How was I able to come up with this conclusion? And for the second graph, we have this. I want you to take note of how each graph looks like. Okay, so it says here that it has moderate negative linear relationship. So what is the meaning of those things? So as we go on, we will discuss the meaning of this conclusion. So there you have it. What you have right here is what we call a scatter plot. A scatter plot gives a visual display or graphical representation of the relationships between two variables. It consists of a series of points plotted on a rectangular coordinate plane. The x-axis represents the independent variable, and while the dependent variable is represented by the y-axis. So we use the scatter plot in correlation analysis. What do you mean by correlation analysis? It is the statistical procedure used to determine and describe the relationship. Everybody repeat the word relationship between two variables. So when we say correlation, it is the relationship between two variables. How related is one variable to another variable? Now, The relationship of correlation between two variables may be described in terms of strength and direction. So the trend line is a diagonal line closest to the point, which tells the direction of correlation that exists between the variables. The direction of correlation may be positive, it may also be negative or zero. So later on, we will find out what is the meaning of this three direction of correlation. And the last one, the strength of correlation may be perfect, very high or strong, moderately high, moderately low, or very low or weak, and zero. It means when you have a zero correlation, it means that the first variable is not related to the second variable. So what does it mean by a positive correlation, strong positive correlation, weak negative correlation, or zero correlation at all? So let us analyze these graphs. So how do we interpret a scatter plot? Let us look at the first figure. For our x-axis, we have the weight, and for the y-axis, we have the height. We have the weight for our x-axis, and we have the height. Now, if you will notice, after doing the scatter plot or graphing the x and y values or the independent and dependent variables for our scatter plot, we notice a pattern. And for the pattern of the first image, it is going up. From left to right, it is going up. Therefore, we can say if a scatter plot has a pattern that is going up in going in the direction from low to high, we can say that it has a positive correlation. Meaning, when you increase in weight, it is most probably that it is most probable that the height also increases. Okay. So when you when the weight increases, the height probably increases, and vice versa. Okay. Another thing that we should remember is how clustered. When you say clustered, gaano kaipon. The more clustered a scatter plot is, the stronger the relation. The more those points are spread out, it has a weak correlation. Let us look at the second graph. In the second graph, we have two variables, tiredness and hours of sleep. Hours of sleep and tiredness. We can see that the scatter plot or the dots in that second graph is going down. Okay, it is going down. Therefore, if the scatter plot is going down, we can say that it is negatively correlated, or it has a negative correlation. So we should remember that. Okay, when a graph is going up, it has a positive correlation, and when the graph is going down, it has a negative correlation. Now let us look at the third example, the shoe size and the hours of sleep. We can see that there is no definite pattern whether it is going down or going up. Therefore, we cannot determine its direction, and we can say that it has a weak correlation or no correlation at all, simply because the points are scattered. As you remember a while ago, the strength of a correlation is determined by how clustered are those points. So if the points are scattered, we can say that it has a weak or no correlation at all. So the third example, that the shoe size is, it means that the shoe size is not related to the hours of sleep. Okay, your shoe size is not uh, in any way related to the number of hours that you sleep. Am I correct? That is it does it happen that when you have a larger shoe size, do you have more number of hours of sleep? Of course not. They are not related. So that is how we interpret a scatter plot. So for our next activity, match match the scatter plot in column A with its form, direction, and strength in column B. Okay, I will give you 5 minutes to determine the value of those um, scatter plots. Okay, let's do number one. For number one, what is the direction of the graph? Is it going up or going down? It is going down. Okay. So therefore, we can say that it has a negative relationship. That is the direction. But what is the strength of the relationship? So in our options, we have three negative relationships. Okay. But which of those three options is the best interpretation of the scatter plot in number one? The correct answer is strong. Okay, because the points are clustered into almost a straight line going down. So we have letter D. It is a strong negative linear relationship. Number two. For number two, the correct answer is moderate negative linear relationship. Why do you say it is negative? Correct, because it is going down. And why is it only moderate compared to number one, which is strong? Correct, because the points are more scattered as compared to number one. Number three, what is the direction of number three? So the direction is going up, correct. So when you say going up, what does it mean? Is it positive or negative correlation or no correlation? Correct, it is a positive correlation. Now, what is the strength of the correlation? Is it weak, is it moderate, or is it strong? Which of those three options? The correct answer is, we can say that it has uh, weak positive linear relationship, because the dots or the plot or the graph is more scattered. So therefore, we can say that it has weak positive linear relationship. Number four, what's the direction? Correct, it is also positive. But what could be its strength? Yes, the answer is letter B, moderate positive linear relationship. Number five is the same with number one. But if, let's say, hypothetically, if number five, we have the same graph, but instead of going down, it should be going up. What should be the uh, answer for number five? If the graph in number five is going up, the correct answer is a strong positive linear relationship. If the graph in or the scatter plot in number five is going up. Okay, correct. Do you have, if you have, by the way, if you have any questions, you may post your questions here on the YouTube, on my YouTube channel, or you can post your questions on our group chat. So, what have you learned? That when describing the relationship between two variables displayed on a scatter plot, we need to first know the direction, whether it is positive, negative, or zero. When if it is going up, it is positive, correct. When it is going down, it is negative. And if you cannot determine the direction, therefore it is zero correlation. The form, whether it is linear or non-linear. Letter C, the strength, whether it is strong, moderate, or weak. When um, when the scatter plot is, when the points on a scatter plot are more clustered, the correlation is stronger, and when it is more scattered, it becomes a weak correlation. And what do you mean by possible outliers? It is the points that are farthest away from the trend line. Let's say you have a scatter plot that is going up moderately, um, moderately positive correlation, but sometimes there are points that are not along the line. Those are what we call outliers. They are extreme values. No, they are the points that are farthest from the line. Now that the discussion is finished, let us apply the knowledge and skills you have learned in this lesson. So it is now quiz time. For your quiz, answer assessment on your module. Sorry, that is again another typographical error. Pages 13 to 15, put your answers on a one whole sheet of paper to be submitted on the next retrieval and distribution of modules. So that is your quiz to be submitted on the retrieval and distribution of modules. For your assignment, I would like you to have a fun activity. So this is a pair activity. Choose anyone from your classmates that you can easily communicate with online in any platform that you want. You can use Messenger, you can use um, Google Meet. Okay, rank the following 10 food in order from the food you like the most. So the food that you like the most will be rank 1, and then the food that you like the least will be the last position. So there are, I think, 10 different kinds of food here. So you rank your most favorite food as 1 and your least favorite as 10. Okay, you rank your own. Now, why is it a pair activity? Why is it a pair activity? This is the instruction now. Get together through online platform, any online platform that you need or that is most convenient to use with your partner. Write your responses for the 10 items above as ordered pairs. For example, the first item is barbecue. Let's say any of you will be, you can either choose who among your partner will be X and who will be Y. Okay, let's say student A is the first your variable X, and then the other student is variable B. So for example, for barbecue, what is your score and your classmates score for barbecue? Let's say 3 and 4. So you write down the first coordinate for barbecue, and then the next one is pizza. What will be your score for pizza? And then what you're going to do is to plot those scores in a scatter plot. So analyze the data that you're going to have here. What conclusions can you draw based upon your scatter plot? Okay, so that is your assignment. So thank you everyone for listening to our lesson for today and participating. If you have any questions, you can find me at Facebook Messenger through our GCs, through the um, YouTube channel that we have, or you may email me at gracemishagab@gmail.com. That's all. Thank you, and I hope that you have a nice day.